Good morning. Today we are going to discuss about containers in cloud computing. Figure shows general containers used to pack goods to transport. Things kept inside a container can be shipped from one place to another place safely. In cloud computing, the term container refers to a standard unit of software application that packages up code and all its dependencies. It can be transported from one location to another location safely. It can run on any platform. In this class, we are going to discuss about the following. What is a container? What is containerization? What is container orchestration? What are container platforms? For example, LXC, Docker. What are container orchestration platforms? Example, Kubernetes and Docker Swarm. Differences between containers and virtual machines. What is a public cloud virtual machine? Example, Amazon EC2. And what is public cloud container? Example, Amazon ECS. First of all, what is a container? A container is an isolated standalone unit that encapsulates a software application and all its dependencies. It runs consistently in any environment independent of host system. Container is a platform independent software application. See the diagram. There is a server loaded with operating system and there is a container engine which is used to create containers. We can see many containers in the figure. Every container is a separate isolated software application. Every container contains software application, required libraries, operating system kernel. So the container application can run on any machine. It may be a laptop or a desktop or a mobile. What is containerization? Containerization is the method of packing code of a software application together with all its dependencies as a container. In simple, a container is packed with code, libraries, binaries, and operating system kernel to make it execute on any cloud or computer. Containerization is the method of creating lightweight, isolated software units as containers, ensuring portability, high efficiency, and rapid deployment. The software used to create containers are LXC and Docker. LXC is used to create containers using Linux operating system. Docker is an open source software used to create containers in Linux or Windows or Mac OS operating systems. What is container orchestration? Using container engine, we can create any number of independent isolated containers. These containers may be used for different purposes at different locations on different computers in cloud. Managing a single containerized application is relatively straightforward, but scaling to hundreds or thousands of containers across a distributed computers leads to significant challenges in ensuring availability, interconnectivity, and scalability. Container orchestration addresses these complexities. The following are the platforms for container orchestration: Kubernetes and Docker Swarm. Both are open source platforms for container orchestration. Virtual machines versus containers. Figure A shows architecture of virtualization. Hypervisor software is used to divide a single machine into multiple virtual machines. Virtual machine is an abstraction of physical hardware, turning one server into many servers. These servers can be used to create multiple applications. Figure B shows architecture of containerization. The container engine software is used to create multiple containers. Containers are isolated software functionalities. These containers packs code of application along with its dependencies. Every container contains code of the application, its required libraries, and operating system kernel to make it portable across different machines. Differences between containers and virtual machines. The table shows the differences of container and virtual machines in regard to the feature mentioned. The first feature, virtualization level. Container is created as operating system level virtualization. It is only a software package. No hardware is packed in container. Whereas in virtual machine, it is a hardware level virtualization, means it contains virtual hardware and some applications. The second feature, operating system. Container is packed with operating system kernel, whereas virtual machine contains full operating system. Third feature is size. Size of container is in megabytes and size of virtual machine is in gigabytes. Fourth one, boot time. The time to boot container needs only few seconds, whereas virtual machine needs few minutes to boot the virtual machine. Fifth feature, resource usage. The usage of resources is very low as the container contains all the required libraries, whereas in virtual machine, the use of resources is high. Sixth feature, isolation. Container is an isolated software unit. It is treated as process level isolation or application level isolation, whereas virtual machine contains hardware. It is called hardware level virtualization or system level isolation. Seventh feature, portability. Containers are highly portable as they can run on any machine. Virtual machines are less portable comparing to containers as they depend on the software installed. Eighth feature is management. Containers are managed by orchestration software called Kubernetes or Docker Swarm. Virtual machines are managed by hypervisors. Ninth feature, use cases. Containers are used in microservices, web applications, CI or CD pipelines, and cloud native applications. Virtual machines are used in applications requiring strong isolation and diverse operating system requirements. Building blocks of containers. Containers are created like independent isolated software applications. The software containers are built using three core features of the Linux kernel. They are 1. Namespaces, 2. Control groups, 3. Union file system. These technologies work together to isolate processes and manage resources, allowing applications to run in consistent isolated environments. Namespaces creates isolated workspaces for containers using the following namespaces. PID namespace is used for process ID isolation. NET namespace is used to manage network interfaces. MNT namespace is used to mount point isolation. UTS namespace isolates host name and domain name. IPC namespace manages inter-process communication. Control groups ensures that containers do not exceed allocated CPU or memory or disk IO or network bandwidth, preventing a single container from hogging resources. union file system. It maintains layering of files. Technologies like overlay FS allow multiple file systems to be stacked and presented as a single unified file system. Containerization platforms. LXC and Docker are the softwares used to create containers. LXC, Linux container. LXC is used to create containers having Linux kernel. Docker is a software used to create containers with either Windows or Linux or Mac OS kernels. It is a general purpose containerization software. First, let us discuss about LXC, Linux container. An LXC container is an operating system level virtualization method that creates isolated Linux environments on a single host, sharing the host's kernel but providing separate file systems, processes, and networking for each container, making them lightweight software functionalities. LXC uses kernel features like namespaces for process isolation, C groups for resource limits. From the figure, we can observe that the host is loaded with Linux operating system. LXC is applied to create containers. Every container is a software application. Every container performs a different task. The containers has Linux kernel bundled along with code of the application and all the containers created by LX or Linux containers. Key characteristics of LXC containers. LXC containers has the following key characteristics. They are lightweight, system containers, isolation, familiarity. The first one, lightweight. Containers created by LXC are lightweight containers as it shares the host kernel, avoiding the overhead of a full OS boot. System containers. LXC is designed to create Linux containers, unlike Docker, which creates OS independent containers. Isolation. LXC creates isolated containers. It uses Linux kernel features, C groups for resources, namespaces for process or network isolation, for separation of one container from other containers. Familiarity. LXC container functions like a small virtual machine, allowing SSH access, package installs, and updates. Containerization using Docker. What is a Docker? Docker is an OS level containerization platform. Docker is a software which is used to create multiple isolated containers. Docker is written in Go programming language and supports Windows, Mac OS, and Linux operating systems. What is Docker container? A Docker container is a lightweight, runnable instance of a Docker image. It packages the application code together with all its dependencies and runs it in an isolated environment. Containers allow applications to run quickly and consistently across different environments, whether on a developer's laptop or test servers or in any computer in cloud. Figure shows the architecture of Docker containerization. Server may be loaded with Windows or Linux or Mac OS operating systems. Docker software creates isolated containers. Every container contains a separate application and its dependencies. What is Docker? Docker is an OS level containerization platform. Docker is used to create multiple isolated portable containers. Docker containers allows applications to share the host OS kernel instead of running a separate guest OS like in traditional virtualization. This design makes Docker containers lightweight, fast, and portable while keeping them isolated from one another. Docker is written in Go programming language and supports Windows, Mac OS, and Linux operating systems. Docker standardizes the runtime environment by bundling everything, application and dependencies into containers. Characteristics of Docker. There are five characteristics, namely portability, consistency, lightweight, scalability, and efficiency. Let us discuss one by one. First one is portability. Docker containers runs anywhere in local machines or in cloud or in laptop or in desktop or in server or in mobile so that they are portable. Consistency. Docker containers behaves the same when in development or testing or in production environments. Third one is lightweight. Docker containers does not contain full OS to run applications. Instead, it shares the host OS kernel to run applications. Because of this nature, it is called lightweight container. Scalability. Docker offers significant scalability through its lightweight nature and portability. Large scaling requires container orchestration platforms like Kubernetes and Docker Swarm. Next is efficiency. Docker containers starts in seconds as it uses very few system resources. Comparison of Alexei and Docker. The table shows the comparison of Alexei and Docker based on some parameters. We are going to discuss the functionality of Alexei and Docker on the parameters mentioned. First parameter developed by Alexei was created by IBM, Virtuoso, Google, and Eric Biederman. Docker was created by Solomon Hykes in 2003. Data retrieval. Alexei does not support data retrieval after it is processed. Docker. Data retrieval is supported in Docker. Next parameter, usability. It is a multi-purpose solution for virtualization in Alexei, whereas in Docker, it is a single-purpose solution. Next parameter, platform. Alexei is supported only on Linux platform. Docker supports platform-independent containerization. Next parameter, virtualization. Alexei provides full system virtualization. Docker provides application virtualization. Cloud support. There is no need for cloud storage as Linux provides each feature. Docker. The need of cloud storage is required for a sizable ecosystem. Popularity. Due to some constraints, Alexei is not much popular among the developers. Docker. Docker is popular due to its OS independent nature. Speed of deployment. Alexei containers are lightweight and consumes more time comparing to Docker containers. Docker containers are lightweight and fast. Container orchestration. Managing a single containerized application is relatively straightforward, but scaling to hundreds or thousands of containers across a distributed system introduces significant challenges in ensuring availability, interconnectivity, and scalability. Container orchestration addresses these complexities. Container orchestration is the automated management of entire life cycle of containerized applications, including deployment, scaling, networking, and health monitoring. It enables organizations to manage hundreds or thousands of containers across various environments without manual intervention, ensuring high availability, load balancing, and efficient resource allocation. Examples: Docker Swarm and Kubernetes are open source container orchestration platforms used for managing, deploying, and scaling containerized applications across a cluster of machines. Kubernetes. Kubernetes is an open source container orchestration platform designed to automate the deployment, scaling, and management of cluster of containers. Kubernetes was developed by Google. Kubernetes manages cluster of containers with efficient resource allocation, self-healing, and load balancing for cloud native applications. Key functions of Kubernetes orchestration. Kubernetes automates several critical functions that would otherwise require significant manual effort. These core capabilities are what makes it such a powerful orchestration platform. They are deployment, scaling, self healing, load balancing, and resource allocation. Let us discuss them one by one. Deployment. In Kubernetes, deployment is a key resource object that manages the deployment and lifecycle of containerized applications. A deployment provides updates for pods or replicas. Scaling. It allows scaling the number of application replicas up or down based on CPU usage or other metrics. Self healing. It fixes failures without human intervention by restarting failed containers, replacing dead nodes, rescheduling workloads from failed nodes. Fourth one, load balancing. Kubernetes handles load balancing between nodes. It automatically distributes traffic to the healthy nodes associated with that service. Resource allocation. Kubernetes manages resource allocation using requests and limits for CPU and memory. The system ensures fair distribution and prevents resource exhaustion using dynamic resource allocation DRA. Let us discuss about Docker Swarm. Docker Swarm is a native feature for container orchestration integrated directly into the Docker engine. It allows developers and administrators to manage cluster of Docker nodes as a single virtual system. The features of Docker Swarm are simplicity, high availability, load balancing, scaling of containerized applications, and security. Let us discuss them one by one. Simplicity. Managing containers is easy with Docker Swarm. High availability. If a container fails, the Docker Swarm manager automatically reschedules tasks on available containers. Load balancing. Docker Swarm automatically distributes incoming requests across all healthy and running tasks within the cluster. Scaling. Services can be easily scaled up or down using a simple command to meet the demand. Security. Communication between nodes is secure by default with mutual TLS authentication and encryption. Next is advantages of Docker Swarm. Ease of use, built-in orchestration, and integration with Docker ecosystem. It is very easy to use Docker Swarm to manage cluster of containers. Docker Swarm is integrated with Docker, so it has inbuilt orchestration capability. Then disadvantages of Docker Swarm. It has limited feature set compared to Kubernetes. It supports smaller community and ecosystem. Public cloud virtual machine and public cloud container. AWS is the leading company which offers cloud services to general public in the form of virtual machines and containers. AWS offers Amazon EC2 for virtual machines and Amazon ECS for containers. EC2 stands for Elastic Compute Cloud and ECS stands for Elastic Container Services. Let us discuss about Amazon EC2. EC2 stands for Elastic Compute Cloud. Amazon EC2 offers virtual servers on rent. The name EC2 itself explains its core value. The three words Elastic Compute Cloud has specific meanings and features that satisfies the core value. Elastic. You can easily increase or decrease the number of instances or their size as your needs change. Compute. It provides processing power, memory, and storage for your workloads. Cloud. It runs on AWS massive global data center infrastructure. AWS provides secure, resizable virtual servers in the cloud, allowing users to customize compute, memory, storage, and networking resources on demand. Amazon EC2 offers virtual servers on rent, allowing users to do their applications without buying physical hardware. EC2 enables rapid deployment of applications with flexible purchase options and automatic scaling. Key benefits: elasticity, cost effective, control, reliability. Elasticity. It scales up or down the computing capacity dynamically. Cost effective. EC2 offers pay as you go model, allows you to pay for what you use. Control allows user to have full control over operating system and environment. Reliability. EC2 has been built on AWS robust global infrastructure with high availability option. So it is very reliable. Working of AWS EC2. Instead of buying and managing your own servers, EC2 offers you virtual servers on rent where you can run websites, applications, or even big data tasks. The key functionalities of EC2 are virtual server management, instance customization, scalability and reliability, storage options, networking and security, high performance computing, and rapid deployment. Let us discuss one by one. Virtual server management. EC2 manages virtual machines using various operating systems. Different virtual machine may have different OS and different middleware. Instance customization. User can choose and optimize compute power, memory, storage, and networking resources based on demand. Every user can have his own configuration. Scaling and reliability. Easily scales the capacity of resources up or down based on load requirements. Storage options. It allows dynamic storage options. Networking and security. Allows to configure security groups, firewalls, and networking settings to control traffic and access to instances. High performance computing utilizes advanced networking GPU and high performance processors for distributed computing tasks. Rapid deployment allows rapid deployment of applications. Amazon Elastic Container Service. Amazon Elastic Container Service is a fully managed, highly scalable container orchestration service that helps you easily deploy, manage, and scale containerized applications in cloud. ECS is used to manage clusters of containers across networks. Amazon ECS is integrated with AWS tools and third party tools such as Docker. You can run and scale your container workloads across AWS regions in the cloud. Key benefits of ECS: scalability, simplified operations, flexibility, high availability, security, cost effective. First, scalability. It effortlessly scales applications to handle load from a single container to thousands of containers. Simplified operations. It automates cluster management and container lifecycle flexibility. ECS supports various Docker registries and handles workloads via ECS Anywhere. High availability. ECS provides built-in availability and fault tolerance, ensuring that your applications are always up and running. Security. ECS provides a secure environment to run your applications with features such as IAM, identity and access management, roles for tasks, VPC isolation, and encryption at rest. Cost effective. ECS enables you to optimize your infrastructure costs by scaling resources based on demand and only pay for what you use.